Today's presentation is, Was There Life on Mars? The Monuments Speak. It seems to be a fairly interesting topic, I can tell by the number of people who've come out for this. And there seems to be several controversial areas involved in this too. But I hope that this can be handled in good taste. Today's speaker is Richard Hoagland, and he'll be talking about some work that's been done in analyzing some Viking data. And more specifically, he'll be talking about the results of some fractal analysis that has been done on some of the features in the Viking data. And also, they'll be talking about some mathematical and trigonometric relationships that are obvious in the features. So, without further ado, I'd like for you to welcome Richard Hoagland.
If I can get the technology here working. Thank you. It's very nice to see this turnout. I hope we will have some interesting things to present to you. We have a lot of material, a lot of data to go through in a very limited period of time. Let me give you a couple of points of reference, context. Valerie said this is controversial. It's controversial on two levels. It's intensely controversial because there is a tremendous step function in the idea that we may have found evidence that the human race is not alone. The evidence we have been looking at is not the kind of evidence that we ever imagined we would look at. The paradigm for the last 30 years has been that ET would phone home, or at least phone Earth. And any data that goes against that paradigm has a very difficult time making it in the marketplace of ideas. What we're going to try to show you is some data that goes against that paradigm. It is conceivable that we are looking at ET-generated physical evidence on the surface of Mars. Now, is that tantamount to saying that there were Martians? No. One of the misconceptions is that we are saying that there were little green guys on Mars. Not in the slightest. There have been many papers in the literature in the last 10 years showing that with our own demonstrable technological advances within the next 10, 20, 30, 50 years, we will be able to mount interstellar missions if somebody wants to pay for them. What we are looking at is the possible artifactual evidence of somebody who wanted to pay for an interstellar mission. It's that simple. If we're looking at real stuff, it is our contention that the Mars environment given to us by Mariner and Viking data does not allow for the indigenous presence of the guys who did it. If it's real, it was done by somebody who came from someplace else. Now, I want to put that as the frame, because once you say that, a lot of the puzzling aspects of the data become more easily understandable, including the scale of the features we are seeing. Some of the things are very large. They're in the order of a mile. Well, if they had the purpose to attract our attention, they'd have to be that large in order for it to be reasonably guaranteed they'd be photographed someday and recognized. If the geometry and the mathematical material we're going to show you is substantive, then that's another reason why the scale had to be large so that it would be unmistakable. This all started 12 years ago when NASA published in some of its Viking material this photograph. It was found 2 or 3 years after the Viking mission in '79 by two gentlemen who worked here at Goddard, Vince DiPietro and Gregory Molinar, and they had suffered no mean amount of abuse for raising the issue that in fact this object was interesting, was important. Vince and Greg did a courageous thing. They pursued, in the face of opposition that was not fair, that was at times mean-spirited, an inquiry into could this in fact be more than merely a trick of light and shadow. And the data that we are discussing this afternoon has come directly because of their persistent efforts. This now is an enhanced version a la Mark Carlotto of the famous face, the head. What you can see here is that in the mouth there appear to be teeth. There's a funny thing here under the eye that's been termed the eye drop. There's a rather remarkable symmetry. This is a low sun angle. You can see the long shadow. There is definite indication of symmetry in this view. The processing has brought up illumination from the sky. Mars has a bright sky, as we now know from Viking. You can actually see the back illumination of the shadowed side. There is a symmetry to the platform. It's an interesting object, but is it anything more? Are we projecting a Rorschach test, which has been the claim by most critics for 12 years. Well, that is what the Mars Project has been trying to find out. With that as prologue, let me turn you over to Dr. Carlotto, who is the Mars Project's imaging scientist. He is an imaging scientist at the Analytical Sciences Corporation in Reading, and he has been doing some very intriguing things with the 12-year-old NASA data tapes, and I would like to let him show them to you right now.
Thanks, Dick. Let's get this on. Valerie has a copy of the manuscript that was recently submitted for publication to Nature. What I'd like to talk about is some work that we've been doing for about a year in the area of applying fractal modeling techniques to some of the Viking data. I got interested in this back in '85 and published a paper in the May issue of Applied Optics that gives a little bit of background. As Dick mentioned, SETI has been primarily a radio search since 1960, since Drake started Project Ozma. The issues are, where do you look? There's a tremendous search space in frequency and in direction. As the technology gets better, you have to look in more directions and at more frequencies. What are we looking for? We don't really know what the signal is. And when we find something, how do we know that it's a message? There have been a few papers in the literature written on star maps that have been decoded from signals, but how do we really know it's real? Something a little bit more concrete that has been proposed recently has been to look for probes near Earth in the asteroid belt and fairly recently on planetary surfaces. These are published in Journal of the British Interplanetary Society, Icarus, spaceflight journals. Foster's paper was the point of departure for our work. The idea there is that there may be deranged planetary terrain or features that are detectable by remote sensing. So what we're trying to do here is define criteria for identifying possible non-natural objects on planetary surfaces, develop techniques for detecting such objects in imagery, robust techniques, analyze the data that we have. There's 60,000 or so images that deserve a good looking at. And then lastly, to develop a broader search strategy for SETI, to try to broaden the SETI charter by looking at some of this imagery. Okay, with fractals as a baseline then, we wanted to detect something that's man-made, something that's unexpected. We don't have a model for it. This is sort of the recurring thing in the SETI community. We're looking for something, we don't know what's out there. How alien is alien? What we're trying to do here is establish a very conservative kind of model. That is, one based on modeling the background. We know what natural is. If we can remove that, what's left, who knows? It may be natural or otherwise. This is upper left, 4 military vehicles embedded in a fairly complex background. This is the local fractal dimension, and the details of how this is computed is in the paper, but essentially it's a sliding window that within that window you compute the dimension of the image intensity surface and you compute the model fit. That is the error that is incurred in assuming fractal behavior. So man-made objects have a higher fractal dimension than the background and also a higher model fit. Let me go right to the area of interest. This is in the Cydonia region of Mars. It's about 325 square kilometers. These are 3 Viking frames, 35A72, 3, and 4. This feature here is often called the face, because to some people it looks like a face, to others it looks just like a rock formation. This is the D&M pyramid. Erol will talk more about this later. It's a 5-sided pyramid, or 5-sided object. There's some polyhedral objects of interesting shape here, and this is called a cliff. These are just, I'm using these terms as landmarks. This is the area that we process. It's 1280 by 1024. When we ran the technique using the same parameters for the that example with the military vehicles, looking at the model fit error, that is the deviation from fractal behavior, we find that the face and a few objects in the city have the highest fractal model fit error. There's some areas here that also have high value, but you see for the most part the background is fairly low. Blue is low, red is high. That's only to say that based on this criterion, that those are the most non-natural, the least self-similar objects. It's a relative judgment. There's nothing absolute about it, but it's interesting. These are the two views that we have of the face. If I'm not careful, I'm going to pull this out again. 35A72 and 7813. These are the fractal model fit error images. We see here fewer false alarms. These are caused by dropouts in the data, salt and pepper noise due to data transmission errors. We see fewer false alarms. Neglecting these, we have really the only significant hit on the face here, whereas here we have a hit on the face as well as on some of these other mesas and knobs nearby. Again, the reason I think this is happening is that you have a much lower sun angle here. That is, the zenith angle is much higher. It's only about 10 degrees from the horizon here. Here it's about 15 degrees higher. So you're getting more shading information. So my contention is that some information is being lost here. But again, these are only preliminary results. So that's basically it.
We have to have a handoff of the mic, I guess.
Yeah.
The next speaker will be Erol Torun from the Defense Mapping Agency, who's been working on some rather interesting properties of one of the objects that Mark has looked at with the fractal. And he will be going next as soon as the handoff of the infamous mic takes place.
Just a moment while I get wired up here. Okay. Well, good afternoon. I'm glad to have this opportunity to speak with you for a few minutes about some of the research I've been doing in connection with these objects in Cydonia. Now, I have focused my interest on one of the objects that Mark has just showed you, the so-called DNN pyramid. This is another view of the DNN pyramid, also processed by Mark Carlotto a few years ago. Here we see a more or less five-sided pyramidal object with 1, 2, 3, 4, 5 edges. What appears to be an impact crater of some type here, as well as some disturbance on this side and some uplift, some perhaps debris flow around the edge here. I'd like to show you this object in context with the geomorphology of Mars. We look at the DNN pyramid, we see a more or less symmetrical object. We have a corner here and a corner there. We also have a peculiar flat area here. If we were to assume that there was a wind direction coming this way, one would not expect to see a flat area exposed to the front, because that's the portion that would be subjected to the largest amount of abrasion from wind-carried particles. Additionally, if we were to assume that by some freak act of nature, wind were to array itself in different directions, a perfect symmetry, we would also not see an object like this. What would happen is that the wind coming from this direction might very well cut an edge. Turbulence from locally reversed airflow would pluck material off of this edge and in effect erase this edge. Likewise, if the wind came from this direction, the locally reversed airflow would tend to denude this edge. And the end result of having wind coming from these different directions would be a hemisphere rather than a pyramid. Like for historical interest, I'd show you this old slide. These are the famous pyramids of Elysium that Carl Sagan pointed out to the world after the Mariner mission. They are more or less pyramidal landforms. They are probably the result of slumping and mass wasting. They are not nearly as symmetrical as the DNN pyramid, and they're three-sided rather than five-sided. It is conceivable that they were formed by the wind. You could possibly have wind coming from this direction, cutting that leading edge, and then the locally reversed airflow trimming the rear edge. Now, in examining the DNN pyramid, I went one step further than to simply look at it in its geomorphological context. I also looked at the geometry of the object. I assumed that if the object were at one time symmetrical, that there might be some logic to what these particular angles are. I did that to initially test the assertion in Dick Hoagland's book that the object was bilaterally symmetrical. And in reconstructing the supposed symmetrical form, I discovered that it does have, it is conceivable that it was once bisymmetrical, because it is displaced in this direction, and that appears to be where the impact has disturbed the object. In so measuring it, I also noticed that the front section measures exactly 1/3 of a circle, and not a fraction of a degree more or less. And that struck me as being more than a little unusual. Exploring further, I discovered that this 1/3 of a circle angle, when divided by this angle, equals the square root of 3 to 3 significant digits. Again, struck me as being more than a little unusual. I further discovered that this angle here, divided by this angle, equaled the number, the constant e divided by pi, which someone else had observed equals the tangent of the latitude of the Cydonia complex itself. And I have summarized the mathematics that I found in this object in this diagram. What astonished me most about this was not so much that I continued to find mathematically significant numbers, but that I continued to find these numbers no matter how I looked at the object. To summarize what I have found, I believe that my findings do not definitely indicate that what I'm looking at was deliberately carved. But I do feel that I have found that something in the Cydonia region is very wrong. The object that I'm looking at does not fit the geomorphological context of the Cydonia region or of the rest of Mars. Its geomorphology doesn't fit theory, nor does it fit observation. Furthermore, if I make the assumption, and I will admit that it is an assumption, that the object may have been symmetrical, the geometry that results is extremely elegant. And all of this tells me that it behooves us to find out exactly what has happened in the Cydonia region. It would prove to be a very interesting addition to science. Even if it turns out to be an entirely natural landform, it would mean that something exceptionally bizarre has happened to produce landforms the likes of which are not found anywhere else on Earth or on Mars, and are which currently unexplainable by theory. And of course, if it turns out to be non-natural, then we have a much more interesting problem on our hands. And at this point, I'll turn the podium back to Dick Hoagland, and he'll wrap it up.
Okay. With a modicum of resources, I mean trivial amounts of resources, we have gotten some information which literally is about 24 hours old now, which I want to show you next. And that consists of the following particular set of data. This is a mosaic created by Mark Carlotto. It has been orthographically rectified by the simple expedient of projecting it onto the NASA orthographic mosaic we constructed until the geometry all fits. What you can see is that even in the low sun angle, the processing has brought up this interesting symmetry. The high sun angle, which I think I do have a frame in here, shows a much better version than Erol was able to show you because the contrast is much less. But there are other objects here that are equally intriguing, and when I got involved, it was because there appeared to be a context for the face. It didn't appear to be sitting all by its lonesome. This object appears to have very interesting internal structure as well as rather unusual geometry, as do these and so on. And in the middle of this complex of polyhedral objects, there were 4 little guys which caught my attention because they are arrayed at exactly 90 degrees. They are orthogonal, and we'll show you the axis in a minute. Now the blue lines are latitude and longitude. One of the first things we've noticed, and when I say first, it's only after 5 years we've had accurate data in terms of latitude and longitudes. Mr. Merton Davies at the RAND Corporation, who has done the control points for all of the NASA photography of the deep space missions for the last 20 or some years, has very kindly provided us with the best coordinates now for these objects that we have. Some of them he's provided, some of them he's working on. We know the latitude and longitude of the Tholus and of the so-called city square and of some of the other objects here very precisely. The errors are about 1 kilometer, plus or minus half a kilometer, which is a very good degree of precision given the Viking imagery. One of the things we notice is that the east-west line, the latitude goes right from the center of the polyhedral cluster, or the city, through the Tholus. In fact, one line runs right through the apex, the other line that's parallel runs through the center of those 4 little objects I'll show you in a minute. Now, this is the polyhedral cluster, the city. These are the 4 objects. This is to show that, in fact, they are orthogonal. There's a 5th one in the center. If we look at it without any markings on it, you can see here, this is the best processing we have. The best resolution on the Viking imagery is 50 meters. That's half a football field, 150 feet. Mars Observer will give us 2 meters, maybe 1 meter. Obviously, at that resolution, we will know a lot more than we know now, based purely on resolution. This is the starting point of my investigation, which was to put myself theoretically on the surface back in the middle of these guys. If you stand right there and look out this direction toward the face, it turns out that this is what you will see. The top red line goes across the face, intersects the northern boundary of the cliff. The bottom red line goes past the chin, intersects the southern boundary of the cliff, and that angle is 4.7 degrees, precisely 4.70 on the best mosaics we've been able to prepare now. All right. If we begin to put more optical width lines on, this is the city square line marking the width of the face. All right. This is if you're standing on the apex of the D&M looking at the cliff. It turns out that the width of the cliff from the city square or from the apex of the D&M is identical, 4.70 degrees. It further turns out that if you stand on the nose of the face and look at the Tholus, the optical width is 4.70 degrees. Now, Erol mentioned that many of the constants he has found in terms of angle ratios, radian measure, trig functions in the pyramid have E and pi. It turns out that 4.70 degrees is equal to E times the square root of 3. And 3 and the square root of 3 and E are all numbers which have come up in measurements of the D&M. Isn't it interesting that we are beginning to expand the measurements that he has found in this one structure in terms of the relationships with the other structures? However, it gets more intriguing. If you bisect that angle, all right, that 120 degrees, of course half of it is 60, that line goes directly through the face. And it doesn't go directly across the center between the eyes. What it does is it intersects right here beneath the eye on a feature that DiPietro Molinar called the teardrop, which I showed you a few moments ago. The top red line going to the cliff crosses that feature. That becomes an intersection point. The bottom red line, of course, goes to the base of the cliff, and notice that it meets right at the eastern boundary of that funny-looking crater, which lies just to the southwest of the face. Notice, by the way, that the angle, that the line of the cliff goes right across the nose. This is the surface view that Mark has generated with some very sophisticated algorithms in the computer. This is the little teardrop. Where's my little pointer here? Wonderful. There. All right. There's the teardrop. There's the apex of the nose. The line from the city square goes right across there. And if you turn your head sideways, you'll notice that there's an interesting little riffle here. The cliff would project out just there, so that an intersection of these 3 sight lines is right there. This is a clay model that was constructed by one of our artists in the project named Kinthea. It wound up as the cover of Monuments, the book. This was done, how many years, Mark, before you did the digital? 4 years? 86. Okay. So there's several years separating this, which is a clay 2-inch model, from the from this object. All right. And notice that they are essentially identical. The object that we call the face not only would look like a face when you look at it from orbit, it looks like a face when you view it from the ground, which was a very important starting point for my intrigue and inquiry into this whole thing. Why would anybody, in the model that somebody did this, why would they do it? One of my answers to that rhetorical question was to be seen from the surface. Well, not only can you see it from the surface, as we now can demonstrably see with some very good software applied to the data, but it turns out that it is seen projected against a backdrop which is not randomly placed. That cliff behind it, the sight lines specifically refer to specific parts of it, namely the northern and southern terminus. The one sight line ends here, the other sight line ends here, and here is the detail of this very unusual and intriguing object which has very interesting symmetry, parallel banding. We can get around behind and look at it from the cliff, looking from the crater, looking back toward the face. This is the northern part. The sight line from the city comes in and ends right there. The southern one is right here. This slide's a little dark. This is going to feature next to what I'm going to say, because it turns out that if you run that parallel band right down, you reach the apex of the tholus, and the line between the apex of the D&M and the tholus and the cliff is precisely 90 degrees. These angles, all right? This one, the base of it, you know, at the D&M is of course 60. At the city square, the angle that turns back toward the cliff and goes across the face, that is 69.4, which is the identical angle of the back of the D&M. And this angle is 50.6, where it makes the sharp right-hand turn at the teardrop and goes back to the apex. And all of those angles, and I'll show you in a minute, are significant in terms of the E and the E divided by the square root of 5 relationship, which have been exemplified in the morphology of the pyramid itself. There are ways to say that what we're dealing with is some extraordinary crystalline phenomenon. These relationships, 90 degrees, 120, the morphology of the D&M pyramid is all some unusual and hitherto unknown giant crystallization which only occurs in this one spot on Mars. I don't happen to think that's a valid theory, because it means that all the rest of the Viking interpretive material is extremely suspect. When you invoke magic to explain away some particular set of data, then you're on shaky ground. But let's just imagine that we're dealing with magic. Let's imagine that we're dealing with some hitherto unknown physical phenomenon which manifests itself in these rather interesting and repetitive relationships. There is no way that those relationships could know where these objects are on Mars, at least no way that I can conceive of. What is fascinating is that the planetodetic, which is what's really important, of this complex, in fact, of the D&M pyramid, the line that runs right through the apex of the D&M, and the red lines on both sides are the errors, plus or minus. As you can see, the D&M is bigger than the errors. So no matter how you slice it, this latitude runs through the D&M pyramid. That latitude, turns out, is 40.87 degrees. Why is that an important latitude? Because that is the latitude, what I call the magic latitude, the tan of which is equal to E divided by pi, which has shown up again and again and again in the relationships between these objects, separately as E, as pi, and together as E divided by pi, as pi divided by E. Somehow this complex knows to put itself at the one place on Mars in terms of latitude where there is an integration between where you are on the planet and what the numbers seem to be trying to tell us of the relationships between these objects. Furthermore, the latitude doesn't simply wander down between any of them. It actually goes through the apex of the Rosetta Stone, the one object that embodies those constants and the relationships between those constants. In the SETI paradigm, where Carl talks about the only language we would ever have that would be in common between a them and an us is scientific or mathematics, we have found a set of mathematics that is somehow trying, I think, to communicate something important that we as a culture should follow up. And for 12 years, we have been sitting on our collective hands, and we have not done that. If you were to construct a complex and lay it out mathematically so that someone at some point, at some time, could photograph it and know two things. One is, yes, there was a message, because the mathematics is redundant, then maybe this is what you would do. Notice I'm not saying this is what has been done. We can't say that yet. But we have enough evidence, as I have been saying around the country for the last year, to at least bring an indictment. We have something here that is provocative, that is not understood, that needs to be understood. It's potentially the holy grail of the last 30 years of the American space program, nay, everyone's space program. It's conceivable that we have found ET-generated artifacts lying right next door. If we are looking at something that's real, it is the most exciting discovery in our lifetime. If we are looking at something that's natural, it is the most bewildering, fascinating set of coincidences. And you can do the numbers yourself. Every one of these alignment coincidences has to be multiplied by the probability of the preceding alignment coincidence, feature by feature. If you simply divide their optical angle into a 360-degree circle, you can work it out yourself. And we're pushing millions to one against chance here, simply on that basis alone. We need to know what it is we are dealing with, and we think that it's possible that we could be dealing with something which could not only change the future of NASA, but could change the future of not only this culture, but other cultures, and we need to know. Thank you. Now what we'll do is we'll bring the other guys up here, and if you have any questions, just feel free. Mark? Errol?
Yeah.
Back here.
How can you go to 4 decimal places?
3.
I did.
You said you're working on 4.
Well, some of them I think we can get to 4. I think some of them are right on. If we are dealing with a complex laid out so that we could look at it and see, the first problem is to take it seriously. The first problem in constructing a message is to let your intended audience know you got a message. Obviously, if anybody smart enough to do this is going to know that the first problem is, how do you know it's real? So part of the philosophy would be to give us enough redundancy, enough mathematical redundancy, so that you would not be worrying past a certain point that it was real. There may be other levels of a message here. There are some indications because of the replication of certain constants with certain of the structures, but we don't know what that message would be at this point if there was. But some of the numbers appear to be so close that we think that if it's 4, we'll get the next decimal, or we'll get the next significant figure. And again, that's another part of the redundancy. Some of them will be very, very active. They have to be.
But I think it is 85, what was it, 85?
85.3 is the side angle.
How can you take that one then, upon the sign of that, and say it's going to be accurate to 4 decimal places?
Well, he did
It isn't yet. With my figures, I'm not claiming it's accurate 4 decimal places. What Dick was saying is that when we get the new geodetic information that Merck Davies is working for us, we may be able to fix the accuracy of the angles between the larger objects.
So that particular angle, is that one that perhaps was a little disturbed by that impact crater, or is it a different one?
No, I don't think it's disturbed, and I'll tell you why. Because it is the side angle of the D&M. This angle here, and there's another one here, all right, that's the 85.3. It's replicated precisely 2 other places in the complex. It's replicated here, this angle up here, as you extend the central axis of the D&M and cross the face and cross that little teardrop and continue on to the upper part of the face. You then make a sharp right turn and come down to the tip of the thallus. That angle is 85.3 degrees. And that's 34.7, which is half the back angle of the D&M and half the angle of the city square face line right there. Now, there's another angle. If you run a line up here to the base of the cliff and run it to the chin of the face and back to the thallus, that angle is 85.3, and that angle is 34.7. So the redundancy of the angles and the redundancy of constants separate from the angles is what makes this provocative.
It's like if you don't get it once, you'll get it over here, over here. Remember, there's also a problem with resolution. If this was done to be photographed, there was no way they could know the resolution limits of our technology. There's obviously a lower bound where it doesn't work, where you simply don't have enough information to make these kind of judgments. As you go up that curve, you get better and better data, tighter and tighter resolution, so you're defining these points and you're going to measure these angles or the spacing, which is the same thing, to a finer and finer degree, so you're going to push the number of significant figures out. This angle, this 120 degrees, I would imagine is really going to be right on and precise. This angle, 90 degrees, I would imagine is going to go 4, 5, all right? Those are the kind of baseline anchors. The rest of it is going to be some kind of a mean fit, because as Erol said, you can't run them all out, but that's the intention. The intention is, if there is intention here, to get enough so you get the idea, so they get your attention. And yes, they got our attention.
Yeah, I think we're going to have to wrap up, unfortunately. Anybody else who wants to continue this, just come on up to the front, and we'll be glad to entertain questions for as long as they let us stay around. Thank you. Thank you very much for coming.
Thank you.